Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Claisen rearrangement. So this is also an example of rearrangement reaction. Generally in rearrangement reaction, what happens? The transfer of an atom or group from the one portion of the molecule to the another portion. That we need to observe. Okay. If you see the statement, rearrangement of allyl vinyl ethers to gamma delta unsaturated carbonyl compounds. That means here the reactants are allyl vinyl ethers. Ether means what kind of bond we need to observe? Carbon, oxygen, carbon or not? So one side we must have allyl group, another side we must have vinyl group. Then we can say that molecule is allyl vinyl ether. See this? Here is the oxygen, right side allyl group is there. CH2, CH, CH2. Double bond attached carbon is commonly called as allylic carbon or not. So this is the allyl group. Vinyl group means this one. CH2 double bond CH. This is vinyl. The overall is allyl. Extended carbon is allyl. This one is vinyl. So this double bond C. So oxygen directly connected to C double bond C. This is vinyl. This one is allyl. Involving in the rearrangement under thermal conditions to produce gamma delta unsaturated carbonyl compound. Carbonyl compound means it may be aldehyde or ketone. But the aldehyde or ketone should have gamma delta unsaturation. One pi bond must be there between the gamma carbon and the delta carbon. See this? C double bond O. If you put H here, that is aldehyde. If you put CH3 here, that is ketone. Okay. So with respective to this C double bond O, this is alpha carbon, beta carbon, gamma carbon, delta carbon. In between the gamma and delta carbon, we are having pi bond or not. So that's why this is an example of rearrangement reaction. Okay. So if you see the mechanism, one thing is that the people are saying this reaction is an example of 3,3 sigmatropic rearrangement. What is the meaning of 3,3 sigmatropic? At the third positions, we should have the formation of a sigma bond. For that purpose, what the people are doing, see this. We have this allyl vinyl ether or not? So in case of the allylic group, what the people are saying, start the numbering from the allylic carbon. Allylic carbon 1, 2, 3. In case of the left side portion, what should we do? We need to start the numbering from the oxygen. Oxygen and vinyl group. 2, 3. 1, 2, 3. This is 1, 2, 3. So this bond is subjected to cleavage and this bond is going to be formed between the third atom and the third atom. Sigma bond formation during the rearrangement. That's why it is 3,3 sigmatropic rearrangement. See this? Generally, if we speak now, the pi bonding electrons moving towards this side means here we are getting the double bond or not. So here this carbon will have positive charge or not. Here the valency is increased. That's why these pi bonding electron forming a pi bond between the carbon and oxygen. Here the valency will increase. That's why these pi bonding electrons moving towards this carbon. So this carbon will come up with minus charge or not, negative or not. So this negative and this positive both will form a single bond. But here we are not observing any kind of the ion formation. Here we are observing the cyclic transition state. That's why how we are representing the cyclic transition state. The new bond is formed between 3 and 3 or not. That's why dotted lines. The pi bond is cleaving or not. That's why dotted lines. Here pi bond formation takes place or not. That's why dotted lines. The single bond is cleaving or not. That's why dotted lines. Here we are generating the pi bond or not. That's why dotted lines. Okay, once this is subjected to decomposition, we will come up with the corresponding gamma delta unsaturated carbonyl compound. Okay, suppose if the vinylic group is replaced with benzene, see, if this vinylic group is replaced with benzene, That is commonly called as phenyl group. So at that time the reactant will be allyl phenyl ether. One side allyl group, another side phenyl group. This is extension of the vinyl or not? If suppose if you put like this is vinyl or not? This is the extension of vinyl. Okay, that's why this rearrangement is aromatic Claisen rearrangement. In this aromatic Claisen rearrangement, what we are observing, the products are orthoallyl phenols. The corresponding phenols we are getting. So here what should we get? Carbonyl compounds or not? But here we are coming up with phenol. But initially what happens, we will come up with a carbonyl compound, ketone, that will be involved in the ketoenol tautomerism. Due to the ketoenol tautomerism phenomena, the final product will be the phenol. Okay, let's see. See this one. Oxygen attached benzene ring is going to have the numbering 1, 2, 3. Allylic carbon 1, 2, 3. So here we are going to form a single bond, right? Single bond formation. Pi bond is removing, dotted. Pi bond is forming, dotted. Single bond is cleaving, dotted. Pi bond is forming, dotted. So here pi bond is formed, C double bond O. Now see, in order to attain the stability, what is happening? This keto group is converted into enolic form to get the complete benzene ring. That's why the H is forming a pi bond and removed in the form of H plus. These pi bonding electrons move towards oxygen, means O minus. The O minus and H plus to form OH. Okay. If you see some of the examples, this is the direct example. Right side allylic group, left side phenyl group. So 3,3 sigmatropic rearrangement, we will come up with the corresponding phenols. But if you see this example, here at the ortho position, already this position is blocked by CH3. That's why we are coming up with para compound. Otherwise, we should have orthoallyl phenols or not. But this is para position. Why? Because ortho positions are already blocked. That's why the group is transferred to the para position. Okay. The next. Sometimes in the examination, what happens? We may not get the direct example. See this one. Oxygen is there. Left side we are having allylic group, but right side it is C double bond O CH3. So right side we should have a pi bond or not, vinylic group or not. So we need to create initially pi bond here. Vinylic group generation should be takes place. For that purpose, what we are doing, we are using a strong base LDA. What the LDA will do, it will remove a proton from this acidic carbon. Why? Because carbon is connected to electron withdrawing group or not. That's why this carbon is acidic in nature or not. So here we can easily generate a proton by using the strong base. That's why what happens, we will come up with CH2 minus. CH2 minus will form a pi bond between two carbons, thereby the oxygen electron, pi bonding electrons move towards the oxygen. So oxygen will take minus charge or not? O minus. Here Cl is removed in the form of Cl minus. So Si will take positive charge or not? So O minus and Si plus. So what happened? OSIMe3. OSIMe3. Here we have removed H and Cl. So HCl will be removed. Okay. Now it is involving in the Claisen rearrangement. So we are coming up with this kind of moiety. This is subjected to hydrolysis. H plus and OH minus. So this is H plus come here and OH minus come here. Thereby Me3SiOH will be removed and this will come up with acidic group. Okay, this is called Ireland Claisen rearrangement. So here we are having one more or we can say two more types of Claisen rearrangement. One is Eisenhower Claisen rearrangement, another one is Johnson Claisen rearrangement. Here what is happening, see this. Initially we have taken allylic alcohol, CH2 double bond CH2COH, allylic alcohol. The allylic alcohol is initially treated with this kind of moiety. The molecule in which the carbon containing 2 OR groups and 1 NR2 group and 1 CH3. Okay. R is a CH3 group generally. OCH3, OCH3, NCH3, CH3 and CH3. So initially what happens? This hydrogen and OR removed in the form of ROH. Thereby the oxygen connected to carbon. See, oxygen connected to carbon. Now this carbon having OR NR2 CH3. OR NR2 CH3. Here what happens? From the CH3 hydrogen and OR minus removed in the form of ROH. Thereby we are coming up with the pi bond NR2. Now see, oxygen one side allylic group, another side vinylic group. So vinylic group generation takes place or not? With NR2. That's why C. See this one. OR, OR, NR2. This is CH3. So we are coming up with this one. Here we are subjected to Claisen rearrangement. The corresponding amide will form. Okay. This is Eisenhower Claisen rearrangement. In case of the Johnson Claisen rearrangement, what happens? Here we are having NR2. No? This is also replaced with one more OR. 3 OR groups here. So NR2 should be replaced with OR. So it will become ester or not. So amides will generated, esters will generated, acids will generated, phenols will generated, and the corresponding carbonyl compounds with a pi bond will also be generated. So these are the applications of your Claisen rearrangement. Okay. So thank you very much. Thank you.